Hi there, welcome back. This video is actually a report on the various stages that have taken place since the last time I recorded, and the result has actually been quite pleasing, but I'll give you a bit of a rundown as to the stages this thing went through. The first thing I did obviously was to replace all the caps, and as you can see they kind of stick out, don't they? All the caps replaced were actually on this side, as you can probably tell, and here on the RF section there was nothing to replace, obviously, except for those two filter caps. But as far as the other capacitors are concerned, nothing was out of place, nothing was wrong. Even that over there, it measures exactly right. This is a 1.5 nanofarad, and it's measuring 1.51. So everything else there seemed to be okay, and the result after this work was that the sound was coming through a little bit louder. As pointed out by one of the viewers, that little guy down there is actually the AGC capacitor, and I think that the swapping out of that one had the most effect, because the AGC capacitor, if it's not doing its job, will actually reduce the gain more than it should do on all the tubes. And this is the debris that resulted. All these caps are leaking like crazy. They measure way off the charts. They're all wrong, so replacing them had to have some effect. However, it was not the effect I was looking for. I got the reception, the very low reception that I had before, slightly improved, and but still nowhere near what it should have been. On the medium wave band, I still got absolutely nothing. So that was not the main problem here. So I had to go and look a bit further. And that's when it got really interesting. The next thought that I had was that one of the tubes was gone. So to test that, I went looking for some of the voltages on the tubes, and this service manual actually gives us quite a handy chart, and it literally tells you on each of these tubes what some of the voltages are supposed to be. Now, for example, B2, the ECH42 has a hexode and a triode, and it tells you the anode voltage of the hexode should be 230 volts, and the grid 2 voltage should be 67, etc, etc, etc. Now this is assuming that your B++ is 260 and your B+ is 230. I don't have that much at the moment, but I went looking for these voltages anyway, and something came up straight away. That guy over there, 197, was reading exactly 0, which is not good. That's the IRF front-end amplifier. Now if that thing is not doing its job, well, nothing else will get through. So let's look at the schematic and see what that does. Here's the absolute front end of the receiver, and that's your B1, the first tube. So this thing was not getting voltage over here. If it's not getting voltage over here, we just followed back. Where does B+ come from? Well, there's a capacitor, so that's definitely not it. There's a choke. That should go right through. There's a resistor over here, a 10K resistor as it happens, and there's your B+. So I measured here, and I measured the B+. I measured here, and I measured the B+. And then I measured there and got no B+, which meant this guy was open. Now this guy is a choke that's used just to filter out any RF at this point, which is where the RF is taken off through that capacitor to the rest of the circuit, from the supply. So in other words, high frequency cannot get back into the supply. Now that thing, if it's open, it receives no B+. It breaks this circuit. And when I went to check it, that's exactly what I found. And here it is over here. This is the guy here coming from that 10K resistor. Goes through there, and it goes to the tube, to the anode of the tube. Now, what I found this thing had was You can see quite a bit of tarnishing on there, but this has got a coil around here. That base is just a former. It's basically doing nothing. It's just basically to give it 2 pins to solder the end of the coil to. And I found that this coil was open, and you could actually see a bit of a charred spot on there. Now, a couple of things might have happened. It might have been an overcurrent, or because this is on the front end, you could have I think a lightning strike could probably do that as well. But I unwound some of this coil, and from a certain point onwards, it started conducting. It started giving us continuity. So I'd found where the problem was. So I just rewired, resoldered that point on there, made the continuity, and tested it again, and the whole thing changed. I suddenly had reception on all channels again. Now, that was not the end of it. Now, just because we had the capacitors changed and fixed that front end tube's function, did not mean that this was done. What happened was, when I put it on, after that, I certainly got all the noise, as you can hear. The normal radio hiss, as we'd expected, but it was still very weak. So I went one step further, and that is, and we'll do this at the end again, but I did a quick alignment of the 2 IF cans. I fed 452 kilohertz, that's the IF frequency, into the mixer oscillator tube, that's B3, I think it was, B2. And then I tuned these a bit, and there was quite an improvement. I would say this thing more than doubled the sensitivity. Those things had been tampered with, as I'd expected. Now, what probably happens, and happened, and this is very common, that choke opened up, reception went down, so somebody thought, okay, we can tune it there because we see some screws that are sticking out, so they would have tried to get the reception back by messing around with the IF transformers. And of course that was not the problem, so they just made the problem worse. So I did some improving on there, some tuning on there, and this is what we've got. This is now on channel 5 of the shortwave band. Now channel 5 is way up there in the frequency range, 11.6 megahertz to 17.6 megahertz.
ولكن يجب دائما أن نربط هذا
So we are getting it at around the 11, 12, 13 megahertz range. Let me go down a bit more. We're sitting really literally the day after the hurricane, Leslie went through here, so the weather conditions are a bit weird. But reception is still not bad at all. And it gets better in the evening, which is when I did the test last night. Channel 3, we shouldn't get much at this time of day. Let me go to medium wave. Medium wave. Start at the top. There's that Madeiran shortwave transmitter, the only one. This is Canary Islands.
Y además un motorcillo, ¿sabes? Que llega a unos 20 kilómetros por hora. O sea,
Pero no solo la carrera espacial con humanos a bordo es
muy flexible.
son palabras.
palabras del fiscal
Canary
general de
Islands, pretty
Canarias,
strong
Vicente Garrido,
reception
en la
here.
entrega.
And so that's the progress on the reception. And as I said, with a combination of swapping out the old capacitors, fixing that choke that brought this tube back into operation, it was completely dead, and also doing some alignment to correct whatever misalignment had been done, we have the radio back, and it's actually quite a receiver. Now that's to be expected because it's got a dedicated RF amplifier, front-end amplifier, which some of these don't do. The German sets tend to have an ECH81, which acts as the front end and mixer oscillator, so it's all sort of going into one tube, whereas this one separates the function of RF amplification and mixer oscillator into two stages, and then it has the IF, the IF amplifier between the two at that end. So the result here is, I think the radio is actually fixed, and I need now to do a few more adjustments and corrections and so on. I've also done something else which made a big difference. I cleaned out all the pots. This one especially, the switching and the pots were incredibly dirty, so I used some spray, sprayed it out. You have to do it a few times. I mean, the dirt's been in there for quite a while. And all these switches are actually just open to the surface, so they get tarnished quite a bit. So you do that a few times and switch this thing backwards and forwards, you know, a few hundred times, just if you're bored. And then the cleaning has the effect, the scratching goes away, everything else started working well. I've still got quite a bit to do on this, and most of it is actually cosmetic. As you can see, there's still quite a bit of oiling and cleaning to do on this section, and I have to fix the grommets that do the fine-tuning on there with those cores. That's definitely not working well. And after that, I'm going to do actually a full alignment, because this thing gives us all the alignment instructions. These are all variable or trimmer coils and some capacitors. IF tuning will do, IF alignment will do, and then we'll do the RF alignment. Let me show you what they have here to help us with that. These Philips manuals are completely clear. They are very detailed in how you go about things. So they describe everything, literally, component numbers and everything. Then they do it in English, which is quite unusual. I mean, Philips was Dutch, but I presume they built these elsewhere as well. And this particular one has the description in English. This is the IF tuning, you know, set waveband switch to medium wave, turn variable condenser to maximum, blah, blah, blah. Apply to grid 1 of B2 modulated signal of 452 kilocycles per second via capacitor, trim, and then they give you the trimming that you need to do. And then they go one step further, RF and oscillator circuits. They tell you where to put the pointers on the front, on the dials before you start trimming. So this RF section alignment I will do when I have that front plate rebuilt. As I said, I need to rebuild that front plate because the one I've got is completely falling apart, so that I can put all the pointers in place, get all the dial cords working and set up, and put the pointers in place, and then we'll be able to actually do the front end tuning. Then you go one step further and they tell you exactly what to tune and where. So they tell you to put it on medium wave. You would apply the signal to the aerial socket via dummy load. The signal would be a 547 kilohertz and signal, and then you would trim for maximum output. You would trim those three coils, 38, 24 and 26, and those are pretty clearly indicated on the other drawing. Then you change it to 1630 and you change those variable capacitors. Again, that's very, very clear. So shortwave 3, shortwave 2, blah, blah, blah. Now there's something else here. It says here on shortwave 2B, A, C and D, they tell you there's an asterisk there, and it tells you place fine tuning in the middle position of the dial. That's that fine tuning where those two plungers are basically fallen apart. I'll have to do a bit of a guesswork as to where this is supposed to be. Yeah, when this thing is set, recalibrated. Okay, and so the whole thing is pretty clear, and it helps a hell of a lot. These are the currents and voltages of each of the tubes, as I've shown you before. It's brilliant, and then you've got all the components as well. They don't give the component values in the actual schematic. They give you the component reference, and then here they give you the exact details of those values, like capacitor values and the actual order number if you could get them. Now, with the case of the coil that burnt out, it was what is it? What was it? What number was it? It was a 30 ohm coil. I know it came out to 30 ohms. And after I unwound part of it and rewound it, it came out to something like 27 ohms. So we only lost 10% of the DC resistance, which tells me it's that one there. I think it's S25. 30 ohms, and it measured 26.5 or 27 ohms at the end. So I think we've done that, and there's nothing wrong with it. The last thing I want to show you on this particular video is the audio. I'm going to feed a signal into the audio amp section and see what comes out the scope. Now, to test the audio amp, or the AF input, the phono input, I'm feeding a 600 Hertz signal. Oops. It was set for modulation when I was testing the IF. So 600 Hertz signal, I'm putting the amplitude at 300 millivolts RMS. It's about the level of what one would expect from a mobile phone output, for example. That signal is being fed into the back to the IF, to the phono input of the radio. I now go here and I select phono. Put the volume, it's on, but fairly low. I have the output connected to this cable, which goes into the left input of this little dummy load distributor here. Basically what this is going into here, and if I put it onto speaker, if I choose speaker, I hear it in my speakers which are under the desk. If I put dummy, I get it going through some resistors internally so that I can still have the same effect but not the noise. And if I have dummy, I can choose 4 ohms or 8 ohms. In this case, I'm leaving it as 8 ohms. I also then have this across the speaker. I've got a BNC coming out here which goes to the scope. We can then see exactly what the signal looks like across the scope. So that's what it's set up to do. I'm going to change some of the lighting here, the outdoor lights reflecting on the screen, and we'll see what we're getting there. I'm going to put the volume up here, and we should see the signal that's being fed to the dummy load on the scope. There we go. Pretty neat. Very clear, very clean sine wave, no distortion yet. It's only 1 volt RMS at the moment. Let me see when it starts distorting. Now, there the distortion starts, and it gets pretty serious on the bottom end of the signal, but it never clips. Let me change that again. It's basically rounding off the ends. I would guess somewhere there is where it starts getting serious. It's only 2 volts RMS. Now, various factors could be in play here. One, the actual B plus is not as high as it should be. It's actually quite a bit lower than it should be. If I read it now, I'm supposed to be getting 260 volts RMS, volts DC, and what I'm actually getting as of now is 164 because I have the limit on. Now what I'm going to do, I'm going to put it onto some form of clipping like that, and I'm going to bypass the dim bulb tester. See what happens? As the B plus goes up, it allows more excursion of the actual sine wave before clipping. Now, I'm still only getting 224 volts on the B++. Now, that's supposed to be 260. It means that this rectifier tube is dropping a fair amount of voltage on here. But yeah, that's where that is now. That's at 2.5 volts. I suppose if you get to about 3 volts, it starts really showing the clipping on the bottom end there. That has to do with all sorts of things. It's got to do with the rail voltage. It's got to do with the condition of the tubes. It's got to do with the exact bias. And it's also, and very importantly, got to do with the impedance of my resistive load here. Because the actual speaker they use is a 5 ohm speaker. This thing at the moment is getting a resistive load of 8 ohms, so it's not exact. It's not the exact conditions that you would have if you had the speaker in. Now, if I put 4 ohms, obviously it gets lower, and clipping starts happening earlier even. So it's a bit of give and take all round. Something else that's interesting here is the tone controls. And just to demonstrate how these work, I've got a 200 Hertz signal going in here. I've set the volume so we're getting about 2 volts RMS out. There we go, 2.1, 2.2. And I'm going to activate the bass switch, just so you see the difference. Now, that was with the bass on, this is with the bass off. So if I activate the bass switch, it drops, or deactivate it. It's a 2.1 and it comes down to 1.63. Now that effect is even more pronounced if I use a 100 Hertz signal, which is what I've got now. With a 100 Hertz signal, I've got 760 millivolts, and if I give it bass, it goes up to 2.1. So there's a very significant effect on the bass response with that bass activation switch. Now, to test the tone, the treble, which is the variable one, what I need to do is I need to give it a higher value signal. So I'm going to give it 2 kilohertz. So 2 kilohertz takes it into the what one could call the treble range. And I've got the treble on max. Let's just up the signal somewhat. Now, if I turn the treble knob, which is that potentiometer, watch this. As I go clockwise, it's a feedback circuit, so it does wobble a bit. It actually goes right down. That pot still needs cleaning, as you can see. There's a bit of a, see that? That could just be noise. I'll have to confirm that with the speakers, but as you can see, that's the effect of the treble. So that is the tone controls on this amplifier. Anyway, that is the audio section. Absolutely no noise when I turn the volume. And I can confirm that because I heard it on the speakers before. The scratching is gone, and it's working beautifully. So this is perfect for my Bluetooth adaptation. What I'm going to do is put in a Bluetooth receiver inside, feeding the actual phono input, and so this thing will be used, or can be used, to send your Bluetooth music from your iPhone or from your any Bluetooth enabled device to play through your amplifier and the speakers of this radio, which is actually quite cool. So that's about it for now. I think what we'll do now is I'm going to do quite a bit of cosmetic work here, which I don't like but needs to be done. I need to clean parts of the chassis that I haven't cleaned yet. I need to clean the knobs. And then I've got to start working on the woodwork because I've got to rebuild that front panel. Probably going to use MDF. It's easier to work with. I need to replicate exactly that front panel because that one's completely rotted away. And then I'll be ready to come back and report back on the next stages. So thanks for watching. See you soon.